Hello guys, I am Meet Patel and this is my Excel sheet of which I further explain my project. Basically, it's a mini project, and my mini project topic is a consumer willingness to pay for solar panel. First Excel sheet is about instruction, where I can describe some 1 to 15 instructions. First is problem identification, second is a literature review, third is a research question, fourth is a study design, and fifth is a sample design. Also, sixth is a like co-joint attribute and level. Also, seventh is a experimental design builder. In first Excel sheet, I will explain about a problem where I can first is about key issues and problem where basically it's about there are many house owners who are hesitant to invest in solar panel due to cost and lack of awareness for long-term saving and uncertainty on investment. It's also about the factor limit adoption solar energy despite the potential to significantly reduce energy bills. The consequences behind this, they are low willing to pay for residential solar panels, slow down adoption of residential energy solution, which can be result in non and renewable energy sources and high household energy cost over time. There are research gap in this beyond this problem. The studies show that the benefit of solar energy fewer focus specifically on consumer willingness to pay relations to upfront cost and long-term saving. So basically, it's like when we use solar energy, it saves many. There are many cost and reduce some energies. So about this, how my project address this problem. First is problem investigate the key factor, including how homeowners will need to pay solar panels, such as cost, awareness, and preserve benefit. By analyzing these consumer preferences and barriers, it provides insight into improving adoption strategy. It can be find help guide policymakers and companies to design target initiative and outreach programs. The second Excel sheet is about literature review, where I can define some step. The first step is initial search. First, I will start keyword searches such as willingness to pay for solar panel, also residential solar adoption, and there are some the keywords which I can find in Google Scholars, Scopes, and also Scientific Direct. Second is about the screening and solution. In this, there are results based on relevance and the public year for the last 5 to 10 years. And also, I can also focus on economic, social, and behavior factors which influencing solar panel adoption. The second, third step is thematic categorization. Uh, in this, there are basically four steps. Uh, Economic barriers. Second is awareness and perception. So third is policy impact and regional studies on solar adoption. Step four is gap identification, where I can in this step I will describe benefit of solar energy where uh, well documented and few studies address a consumer willingness to pay and detailed analysis of investment behavior. Step 5 is a refinement and focus. A narrow focus to study that directly related to consumer decision making and cost benefit perception of residential solar panels to ensure relevance to the project objective. Uh, there are three most important articles related to my mini project, which provide APA citation and third sentence summary of each. Okay. First is about decision making and behavior change in residential setup of solar PV. There are one APS citation is a Rai V and Macris K in 2012 decision making and behavior change and residential solar PV environmental research letter. Basically, this is the there is a one researcher who found this decision making and the researcher name is Rai V. Matthews K. in 2001, where they can publish in 2012. For this summary, its an article explained that behavior and decision making process of homeowners who adopt a residential solar PV system. It's also highlighted beside cost saving influence and social norms and trust in installer pay a measure. The second, the second, the second important article is about the willingness to pay for solar panel in Australia, which can published by Zender K. Matthews in 2019. In summary, the studies uses discrete choice experiment to access how different attribute of a solar panel affect willingness to pay in Australia's households. The third article is about mixed income housing and urban sustainability. The article is about Contanto CE in 2012, where they can focus on green building feature broadly. This article also light on consumer willingness to pay for sustainable home features, including solar panels. It highlights that willingness varies by income group and suggests the need of an targeted financial policies and education to promote adoption. So this is my question. Basically, this is my question. How much willing to pay people to install solar panel on their home, which would reduce energy bills? The study design is about the uh, the survey base also like discrete choice, experimental and coincident. But I would choose a survey-based descriptive study because of its consumer awareness, attribute, and willingness to pay. Also, because of there are many it's allowed data from how owners are regarding their knowledge, attribute, and willingness to pay. This method is a co-effective and easy to implement within a short time frame. So this is the sample design. There are three samples I have considered. First is simple random sampling. Third is straight sampling, and second is a convenience sampling. Where I can find about my choices is a simple random sampling because it gives a household in target population in uh, equal chance of being selected. This method help reduce bias and ensure that the sample is representative of entire pollution. So this is my attributes and levers. Uh, there are three attributes and there are three levers. First attribute is about installation cost, and there are three levels in level one is a 3,000 euro, level two is a 5,000 euro, level three is a 7,000 euro. The attribute two is a system size, which is capacity in kWh per month. Level one is a 300 kWh month. Level two is a 500 kWh month. Third is a 700 kWh month. Attribute three is about warranty duration. Uh, level one is at 10,000, 10 years. Level two is at 20 years, and level three is at 25 years. This is my co-joint analysis where I can. This is the experimental design builder And this is my table for instrument installment cost and system design. Also warranty period, which I previously explained these attributes. And this is the my levels which I can differ for 12 columns. This is the survey form which I can upload in my Google form where I can respond to it. This is the raw data. Basically, it's 12 raw data, 12 response ID, and this is it's about and the rating. This is the adjustment raw data like installment cost for 3,000 and 7,000, system size for 700 and 3,000, and warranty period. And there is a some rating which I got in my reference. So basically, this is the regression analysis. I will show you how to do regression analysis. So yeah, so first I have choose data. In data, and there I have one option for data analysis. Then I go to down, scroll down, and regression, where I can it's explain input y range, where I can select first is a rating about, yeah, and the input x range is about the, there is a installment cost and the warranty period which I choose for x-axis. First I will select, and then I choose labels. Then I put new exit. New name is regression. Here is my complete regression statistic, where I can this is the multiple multiple regression and R square. I also like standard errors, and there is some ANOVA, and the coefficients standard error and the t-set p-value lower 95 percentage, upper 95 percentage. Also like significance F and the observation, and the R square, and here is a some coefficient for my attributes and levels, and there is a p-value which is more important in my project. uh, so this is the regression analysis which I show you. See, R square is about 1.10 and observation is 1.1. For Innova there are regression, residual, and total. So this is the like first installment cost which I choose for here. There is two data installment cost for 3,000 and 7,000. and there are coefficient for three of them, and the p-value for three of them. Let's go to let's go to regression interpretation here. Uh, Basically it's there is some which I choose here. Uh, you see yellow line and as well as some yellow line. So this is the like detailed description for my project, and which I choose. Uh, 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 there is some calculation where interpretation is a coefficient 3.30, just like predicted value for other variables, and also like installment cost for 3000 is if a coefficient is a minus 0.03 for my project, it's like small and negative impact, it's almost negligible. Also like p-value is a 0.92, it's not statistically significant. It means we can't rely this price effect of maybe effect of outcomes. Also like system size 700 kWh a month. For choose I choose coefficient 0.06. There is a p-value 1.84, and the 90% of coefficients is minus 0.49 and 0.60. For warranty period 20 years, like for coefficient 0.11 for negative impact, and there is a p-value 0.68, not strong evidence for warranty period, like they save solar energy or not. Let's go to slide 13. So here is calculate my total unity of a baseline versus idea product profile. So first is my baseline profile is like installment cost is 3000, and system size 700 kWh month, and warranty period 20 years. So for sum of coefficient is the total coefficient is 3.30, and the for ideal propane I will choose 7000, system size is 300, and warranty period is 25 years. For this total coefficient is 3.62. So I would see that for utility value of 3.30, while the idea profile unity is a 3.62. Basically, it's the values are very higher than this value. Where can I I think consumer truly prefer, and also this is a product towards idea profile where can where I can see product and consumer have great enhancer for market appeal. So there is a some chart path words and attribute importance. So for installment cost, it's so here idea profile, and there is some chart. There are some three part words: installment cost, system size, and warranty period. So there are three charts here: installment cost, warranty, and system size. And there is some attribute important. So it's so in range is 1.90. So here 1.41. This system size is 1.35. It's so here. So there is the last slide is about my prediction consumer choice. So first photo is about 3000. and system size of 500, warranty period is 20. So prediction is 3.16. The profile is about like I would choose 5,000, and there is some prediction cost is to about of 3.3 3.228, and they also profile 3 is about like the cost is 327. So I saw that profile 2 has a highest coefficient, which would suggest a consumer tend to prefer to most. On the other side, profile 1 is a very least profile, where I can see that people have least fewer in among them.